This is Dr. Kavita Singh, Associate Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. So today we are going to discuss a topic called as basic concepts of and foundations of remote sensing. So till now we have studied about photogrammetry. Now we are talking about remote sensing. So basically, what is a remote sensing and how it processes, how it works, and what we do generally with remote sensing, what type of applications we have, what types of remote sensing we have. So this all we are going to discuss in this topic today. So let us understand first thing we are going to know about remote sensing. So before we enter to remote sensing, we are having these different contents like remote sensing process, steps involved in remote sensing process, different platforms for remote sensing, types of remote sensing, and IARE sensor overview, Indian imaging capability, advantages of remote sensing, limitations, applications. So these are all topics and subtopics which are going to cover in this main topic, that is concepts of remote sensing. So first we have to understand about what is remote sensing. So basically remote sensing means it's a kind of sensor we use with the help of the sensor which is fitted remotely. Remote means just a distance. From a distance the sensor will be fit, and from there it will capture the information without touching the object on the ground. So it's like here if we go through the definition of remote sensing. So remote sensing can be defined as it's a art, it's a science, it's a technology of obtaining the information about object without coming into actual contact with it through aerial photography and satellite scanning. So photogrammetry till now which we have studied, that is also a kind of remote sensing, but the difference where we see here is, so in photogrammetry we see that we are using a aerial platform. Now here we are going to use a space platform to just capture the ground information without touching the object. Without touching the object means we are not going and touching the object, but we are able to get the information about the object. So that is called as remote sensing. Remote means it's a distance. From a distance we are able to obtain the information about or acquire the information about the ground surface. So the term remote sensing generally refers to the use of aircraft-based sensor technologies to detect, classify objects on Earth, including on the surface, and in the atmosphere. So it typically involves use of devices such as satellites or aircraft to collect data from a distance. So here basically remote means a distance. So wherever the areas we are not able to reach. So unreachable areas, the remote areas like villages, mountain areas, very remote areas which we are unable to reach. So that kind of areas are captured with the help of remote sensing. So remote sensing is a technology with the help of satellites, with the help of the sensor we are able to acquire the information of the ground objects. So this technology enables the observation, measurements and analysis of the Earth's surface and atmosphere as well as other celestial bodies. So this is about the remote sensing. Now if we talk about the space platforms, or here basically we are going to discuss about the platform called a space platform. We are having three types of platforms. One is ground platform, one you have airborne platform, one you have space platform. So here in this remote sensing, we are going to deal with satellites. We are going to discuss about the satellites, about the space platforms. So space platforms or satellite system comprise of space segment, sensor systems, ground segments. So space segment is satellite put into an orbit. This is the space segment. And sensor system mounted on satellite and is the eye or instrument which observes or transmits information to the ground. Now here ground segment is Earth receiving station. So what happens in a space, we will be having the satellite. Space, we will be having the satellite. With the satellite, sensor will be attached. So This sensor will be sending information to the ground, information to the ground, where we have a receiver station. That receiver station will receive the information in the form of images, satellite images with a high resolution depending on the resolutions of the satellites. Now, next we'll know about remote sensing process, how the remote sensing process works. So how it works, basically how we obtain the images without touching the object. So here is the process. So for remote sensing, we need sunlight. Whenever the sunlight is available, we are able to get the information. Otherwise, we have different sensors. Without sunlight also, they are able to get the information. But basically, remote sensing will work on the photo, means light. Whenever light is available, then only remote sensing process works. So here we have first thing is sunlight. So when the sunlight is available, it falls on the ground, and these are our objects. It's a target. It is called as target. So this target we have, you have a tree, you have a building, you have a different kinds of building, you have a tower here, you have a tree here, or ground features, whatever features you found on the ground, these are called as targets. So first thing what happens, the sunlight passes through the atmosphere. This is the atmosphere, it has to pass through the atmosphere, then it falls on the ground. Then after falling on the ground, we have different types of objects here. Like some features are having rough surface, some features are having smooth surface, some features are in different colors. So all depending on the smoothness and roughness and the type of the feature and color of the feature or water content in the feature, the objects either reflects, either absorbs, either transmits. So this energy, when it falls on the ground, then it sends back the information to the satellite. Satellite is having a sensor over here, so it will capture the information whatever sent from the ground, and then finally it will send to the antenna receiver. So this receiver will be located in the receiver stations, like we have NRSC or ISRO or different organizations where they receive the information. So it has an antenna which receives the information from the satellite. From the satellite, it goes to the computer analyst. From computer analyst, finally we go through the application part. This is the process of remote sensing. It works like this. Now, if we see in a different way, so here we have we see radiation and the atmosphere. We have a radiation and the atmosphere. Second thing we see here is interaction with the target. Right? Interaction with the target. Third thing we see here is energy recorded and converted by the sensor. And next we see here is reception and processing. Just now we have seen in the previous slide. First thing is radiation and the atmosphere, the interaction with the target. Then it goes the energy recorded and converted by the sensor. Then it goes to the reception and the processing. And then finally the interpretation and analysis is done with the help of the images, satellite images. Now these are the again few steps here we have discussed before also. So this is a different way we can see how we process the work. Source, atmosphere interaction, then we have a target here, then we have a sensor here, then transmission goes, then receiving and processing unit, then information to the system, and finally the information comes in the form of output. Next, you have different platforms for remote sensing. So as I said before also, we have different platforms for remote sensing. Like in the previous lectures, we have seen that photogrammetry is it has a platform of aerial platform. So from aerial platform, it captures the information of the object without any physical contact with the object. Now here we are using the space platform. So we have three different types of platforms used for the remote sensing. So that remote sensing is like from distance we are able to capture. It's like normal camera also if we see that camera will capture the information when we click a photo. So it is capturing the information from a distance, right? So it is not going and touching any of the object, but still at a one place it will just capture the information of the object without touching the object. Now like this we have remote sensing with the different platforms here. Now here we have a ground platform, here you have a airborne platform, here you have a spaceborne platform. So for a ground platform you have we use a vehicle like cars we use, or any kind of vehicle which just it is on the roads. So it will be having a camera over here or over here, and it captures the information of the ground from this vehicle from the ground platform. Okay. Then we have a airborne platform like photogrammetry we do. So airborne platform, we have a aeroplane here, helicopter or parachutes we use to capture the information of the ground surface without touching the object. Now, basically, we are talking about the remote sensing of the space platform. So, space platform is like platforms and sensor. It has a satellite. Satellite is having a sensor attached to it, which will capture the ground information without touching the object. So, this all process, these are the platforms we have. Solar energy will be falling on the target and it will be reflected back and it will be captured based on the platforms we use. And further, this processing will be working like data processing, data products of software. These are all outputs of this kind of recordings. So, visual interpretation, digital interpretation, output soft copy, or output hard copies or decision making. So this is how the different platforms are. Now we have example here of ground platform. So what is a ground platform? So as we have discussed in the previous slide, vehicle will be a car or a scooter or any kind of vehicle which is on the roads. So a ground borne platform, so typically it refers as a structure of a system that operates close to or directly on the ground, and this term is commonly used in the transportation and the military operations or military context. So this is one photo taken from the ground platform. So it's a high object photo, because in high object photo you will see it has a horizon here, it has a sky here, and it has a ground over here. So this is taken from the ground platform. This is also kind of remote sensing. Now we have a airborne platform. Airborne platform is a platform. So this is also a kind of remote sensing like photogrammetry we have studied in the previous lectures. So this refers to the vehicle or platform that carries remote sensing instrument and sensor while operating the Earth's atmosphere. So these platforms are used to collect data such as aerial imagery or other types of remote sensing data or above Earth surface. Or airborne platform offers advantages in terms of coverages, flexibility, and ability to access remote or inaccessible areas. Inaccessible areas means where we cannot reach out. So that kind of areas we are able to capture with the help of this kind of sensors. So remote sensing, this is a airborne platform where we get a aerial photograph. So this is an aerial photograph, airborne aerial photograph of Los Angeles when taken. Now we'll see airborne imagery is how it looks like basically. The previous slide, the resolution is somewhat low. It's not so clear. The area, the scale of this imagery is somewhat less. So we are able to see very less details. Here now we'll see a very clear picture of aerial photograph. So this is airborne imagery. You can see very clear imagery of this area. So it's an oblique normal color photo. So very clearly we can identify here we have a stadium, here we have some vegetations, building is there, here a building is there, same kind of image here we have. So normal color infrared photograph and aerial photograph, University of Wisconsin. This is the University of Wisconsin. So it has taken an example for the airborne imagery. Now you have a spaceborne imagery. Spaceborne platform means this imagery is a satellite image. So this satellite image is taken from space platform. So space platform, we have a vehicle called as satellite. Satellite is having a sensor which is in the space, and it captures the information about the ground surface. So spaceborne platform refers to any vehicle, satellite or spacecraft equipped with remote sensing instrument and sensor that operates in outer space. These platforms are used to collect data such as imagery, spectral data, other measurements above the Earth atmosphere. So this is a spaceborne platform. So here, this is a satellite image. We can see the satellite image. Always it comes in a very different color actually. So this comes as a FCC. FCC we call it as false color composite. False color composite means it won't come in a natural color. So if we can identify this portion, it's a water body. So it appears in black. So always it appears in black in color in a satellite image, in a false color composite image. So satellite image, whenever you take a raw image, it will be always in a false color composite. It won't be in a true color. So here with the help of the shape and size and the color or texture, we are able to identify the ground features. Now this one is also a water body. because with this shape we can tell it's a water tank or something like a water body here. So black color wherever you see, it's a water body. So we'll discuss in detail in the coming topics about the satellite images, how we can interpret it. So basically you understand this is a satellite image and it always comes in a false color composite. It never comes in a true color. So this is an example of space platform. Now coming to the types of remote sensing. So till now we have studied about different platforms. Now we have different types of remote sensing. The remote sensing means obtaining the information of an object without touching the object. So we have two types of remote sensing here. One is active, another one is passive. So what is active? What is passive? These are two different types of remote sensing. Nowadays we are obtaining the information. So active remote sensing is mostly we are getting the information from the active one, because it doesn't depend on the sunlight. As I said before also, it needs light to capture the information. Whenever it is daytime, we are able to capture the information. So we have your two types, active and passive. So when we talk about passive, so you can see there is a sun here. So sun will be providing the light. Sun will be providing the light to the ground, and once it provides the light to the ground, so this portion of the globe or this portion of the earth is getting the light here. Now it will capture this portion of the earth surface wherever the light is available. So this totally depends on the sunlight. Totally depends on the sunlight. So whenever it is daytime, passive remote sensing is accessible or it will work. Now when you talk about active, now you can see here there is no sun here. Sun is not available. So what is happening here? This satellite is having a sensor and it has its own source of light. It has its own source of light. That means satellite will be sending the light to the globe. It will send the light to the earth surface, and wherever which portion it is able to capture, which portion it will be available and which portion it is going to capture, it will send the light over here, and same portion will be reflected back to the sensor. So it is having its own source of light. It doesn't depend on the sunlight. Whenever the light is available, passive remote sensing is possible. For active remote sensing, there is no requirement of sunlight. It is having its own source of light and it gives to the earth surface, and wherever the area to be captured, it will. We have a simple example of active remote sensing, like we have a camera like a normal cell phone we use it. It has a camera. So if you want to capture the information in the night time, so what generally we do is we just put on the flashlight, and that flashlight will fall to the object and it will capture the information. So like that this works. So that is an example of an active remote sensing, because the camera is also like we are not touching the object, but we are able to get the information with the help of the light. When sunlight is there, we need not on the flashlight. Whenever the sunlight is not available, we are able to just put on the flashlight and we are able to capture the information. It's a very simple example we have for this active remote sensing. Now here, if you see about the passive, just now what we have discussed is passive means it needs a sun energy, it needs a sunlight to capture the information of the ground surface. Okay, so the sun provides a very convenient source of energy of remote sensing. Sun energy is either reflected, either absorbed, or emitted. So remote sensing system which measures energy that naturally available are called passive sensors. So naturally available are called, the energy that is naturally available are called as passive sensors. So passive sensors can only be used to detect energy when the natural occurring energy is available. So always remember, passive remote sensing needs sunlight. Whenever the sunlight is available, then only we are able to capture the information of the ground surface. Otherwise, we are unable to do. So we have here active sensors. Active sensors means like radars will be working, lidars will be working all the time. It is having all weather capability. Either it is raining, either it is cloudy, either it is windy, either it is dark. So whenever it wants, it is having own source of light. So whenever it wants, it will send the light to the earth surface. This portion, if it wants to capture, it will send the light. If it wants to capture this portion, it will send the light. So whichever portion it requires, it will just send the light, and this will be reflected back to the sensor, and it will capture the information about the ground. So it's very simple way of getting the information without touching the object. So nowadays, most of the things we are able to get the information like navigation information or cell phones we use for calling purpose or internet purpose. That all kind of a sensor is active kind of sensor because it works in all weather, all season, any type of weather it will work. So that all examples are active remote sensor. Now we have here IRS 1C sensors overview. So IRS is Indian remote sensing sensors. The Indian remote sensing sensors we have IRS 1C, 1D, 1B. So this is some examples we have from IRS remote sensing sensors. So sensors are like we have a pan sensor, we have a list 3 sensors, we have a WIF sensor. So WIF is a wide field sensor. This is the linear imaging self scanning sensor. PAN is the panchromatic imaging sensor. So this satellites of Indian remote sensing, it will give the information in these all kind of sensors. Like we have a pan. Pan means it will give you a panchromatic. Pan means we call it as panchromatic. Panchromatic means it will give you the image in black and white. Black and white. So this image colors won't be in a color image. It will always give you in a single band information. So that information will be in a panchromatic black color, the black and white color. Now IRS pan image of Vizag steel plant. So this is the IRS image of steel plant. Now if you see the list 3, so list 3 will give the information in the same image we have here. So it will give the information in color. Color that too, as we have discussed before, FCC. So this color is not the actual color. This is false color composite. This is false color composite. So this will give you in the false color, not in the true colors. So this is list 3 data. So we have list 1, list 2, list 3, even list 4 we have, which gives you the information in single band, 2 bands, 3 bands, 4 bands. So this list 3, it will give you the information in 3 bands, that is red, blue, green band. So this all we'll discuss in detail in the coming topics. Now you have a WIFS. WIFS is a wide field sensor. So this WIFS will showing the parts of Sundarbans in the east coast of India. So WIFS will give you with a less resolution, but it will give you the false color composite. This is also one kind of sensors of IRS. It gives the information about different kinds of resources. So here you have information about the Sundarbans, about the forest. It will give you the information in false color composite. Right. Now we have our Indian imaging capability. Indian imaging capability means our Indian IRS, Indian remote sensing sensors, or Indian remote sensing different kinds of sensor what we have, our satellites. How much it is capable to give the information. So we have capability of, it can give you the information for 1 kilometers, means 1 kilometer resolution. So 1 kilometer to 1 meter resolution, 22 days to every 30 minutes, repetitively, 1 million scale to cadastral level. This is the capability of our Indian remote sensing sensors. So it can give you the 1 kilometer information, it can give you the 360 meters information. This much area is 1 kilometer covers. So it has a very low scale. Low scale means we call it as low scale. We call it as low resolution. So we'll discuss in detail what is resolution later. So it has a low resolution. Now we have 360 meters. This is also low resolution. We can give the information in 188 meters. That means the total area covered is 188 meters. 188 meters on the ground is visible in the image. That is the meaning of 1 kilometer or 360 meters. Now here 1 kilometer meaning means 1 kilometer in the image is visible. 1 kilometer on the ground, it is visible in the image. So whatever features it is of 1 kilometers, they are visible in the image. So this 360 meter means whatever information it is on the ground which is of 360 meter, it is visible in the image. Now you have 188 meters, so whatever information on the ground it is on the ground, that is visible in the photo or satellite. So it seems like we have 72 meters, we have 36 meters, we have 23 meters, you have 5.8 meters, we have 1 meter of resolution. So this is the capability of our Indian remote sensing sensor. Okay, it can give the information to 1 kilometer to 1 meter. So 1 meter means 1 meter on the earth surface. Whatever object we see of 1 meter on the earth surface, that will be visible in the image, that we are able to see in the image. So that is the capability of our Indian remote sensing satellites, and it has a resolution of 1 meter. Okay. Now we have some sample images of IRS. IRS means Indian remote sensing sensors we have. So sample images of IRS 1C 1D sensors. So here a part of Rome, list 3 plus PAN data we have. So list 3 is the, what is list 3? List 3 is which gives the information in FCC. Okay, walls, color, composite, gives the information in FCC. And we have PAN here. PAN means panchromatic. Panchromatic means it gives the information in black and white. Okay, so it will give you the information in black and white. So we can just merge this list 3 and PAN image to get a very clear picture. Like PAN will be always with a good resolution. Good resolution means with a very high resolution scale, and list data will be with a low resolution scale. So if we merge the list data and PAN data, then we can finally get a very clear picture. So here we have some more data, like this is the PAN data of Austin city. You have a Bangkok city PAN data. So if you want this PAN data to be converted to the color image, so we can just take the same area data for the list 3, and both the data we can merge in the software with the help of the software. The software which we use is ADA software that will help us to merge these two type of data to get the clear picture of the area. Now coming to the advantages. So what advantages we have to see. So advantages of remote sensing, we have advantages of remote sensing. It gives a real-time data. Real-time data means whenever we want, whichever day we want, we will get the information. It's like updated information we get. So suppose there is a construction going on in such area. So if you want to see the changes from day 1 to day 5 or day 1 to day 10, it will give you day-to-day information depending on the resolution of the satellite, right? So it will give you the real-time information, and spatial locations and extents of features can be collected accurately. It gives a very accurate information because it has if some sensors which gives in a very high resolution, so it will give you very accurate information about the features, and it's cheaper, and the work will be with the satellites, it will be faster, and it has a different scales. Scales means now we have seen the resolution 1 kilometer to 1 meter, 1 kilometer, 350 meter, 72 meters, 23 meters, 20 meters, 1 kilometer, 1 meters, 0.65 meters. So it has a different scale. So whichever is our project area, whichever we need to work with, we can just decide, we can just take that kind of imagery for our projects. So easy updation, we can just do the updation easily because every day it is having the capability to give the information every day-to-day information it will give you, and it has a repetitive coverage also. It will give everyday information which we can just compare the changes in the land use. So more analytical themes also it will give us. So these are few of the advantages. It has many advantages, but here we are mentioning very few advantages. Now some limitations. Along with the advantages, we have some limitations of remote sensing. So what are the limitations we have? Availability of cloud-free data. That means cloud-free data means whenever we take a satellite image, it has a cloud cover whenever the weather condition is cloudy. So it will capture the data with the cloud itself. So always we have to just remove the clouds and we have to remove the haze. So that is a problem with this data. It is not having the data cloud free. So always when you see a satellite image, you will be seeing the clouds also with the shadow. So that becomes a problem again while processing the image. Now we have a limitations in mapping and smaller areas. So it gives a very huge area information, like in kilometers information. So at a time, if you want to map your entire India, at a time if you want to map your entire world, it will give you the information. So whenever you want to map a smaller village, that is the problem with this kind of data. So village data needs a cadastral information. So that is not possible with the help of the satellite image. We have to go through the cadastral information, the village information. We have to just collect the cadastral data, then only we are able to go with the smaller data. It's a labor intensive processing, like technical persons are required, and it takes lots of time to just process the image, and after processing of the image only we are able to access the data. So processing time will be more, so more laborious time it will take for the processing. So and technical person and skilled person is also required for this process, and cannot hold attributes. So in the satellite image we are unable to show the attributes because it's just a image of an area and comes in a digital format, so it will not hold the attributes. So we, for attributes we have to go with the vectorization process in the GIS. Now you analysis need vectorization, as I have mentioned just now. For analysis it has to go with the vectorization process. So that all vectorization process we do in GIS. We'll be discussing in the coming topics. Now we have softwares, which software we use for the processing of these images. So we have this ADA software, ESI Space, we have ANVI, we have Idrisi, we have Eurovision. So these are different softwares which can be used for the processing of the image. So out of these, we generally use ADAS for processing of the image. Like sometimes if you want to do the haze reduction, cloud-free data, if you want to do noise reduction or something like clarity of the data, brightness and contrast. This all processing we do in this ADA software. Okay. Now coming to the applications of remote sensing. So remote sensing is having a huge applications. So here I have just discussed about a very few applications. So broadly, if we see, remote sensing is having a application in environmental monitoring. So environmental monitoring means remote sensing is widely used to monitor the environmental changes, including deforestation, land use, land cover, urban expansion, and habitat loss. So it will tell you about the deforestation wherever the deforestation process is going on, or any land use, land cover changes are going on. It will just show the changes in the area, and wherever the urban expansion will take place, it will just highlight that areas and it will capture the information without touching the ground feature. And in agriculture, forestry, remote sensing is extensively used in agriculture, forest, crop monitoring, yield estimation, yield prediction, and just growth of the crop also it can be monitored. Like day one, what is the condition of the crop? Day two, what is the condition of the crop? After 10 days, what is the condition of the crop? So monitoring is very helpful with the help of remote sensing. Next, you have natural resource management. So remote sensing contributes to the management, conservation, natural resources such as water, minerals, energy, and it helps in mapping, monitoring the water bodies, identifying the potential mineral deposits, and accessing renewable energy resources like solar and wind. Now you have a geological and geophysical exploration. So geological exploration and geophysical exploration when we talk about. So remote sensing techniques are applied in geological, geophysical exploration, like to map geological structures, to identify mineral deposits, and to detect oil, gas reservoirs, to access the potential and natural hazards such as earthquakes and volcanic eruptions. It is helpful. Now you have oceanography and coastal management. So remote sensing contributes to the study of oceans, coastal areas by monitoring ocean temperature, salinity, currents, marine ecosystems, and it aids in coastal zone management, habitat mapping, marine pollution detection, and fisheries management. So this is very helpful in resource management and coastal management too. Now, next if you see the application in disaster management. So disaster management, it is very, very helpful. It plays a very important role. So wherever the disaster occurs, so it will give you the pre-disaster condition, it will give you the post-disaster condition, and it will give the information about the rehabilitation stage also. And it helps to early detection and monitoring natural disasters, hurricanes, floods, wildfires, earthquakes, landslides, emergency response planning, and damage assessment. Like generally daily we see the weather report. So like predictions, we see that today it is going to rain or it is cloudy or it's sunny. So this all information is given by the remote sensing active remote sensing sensors. So this will give you the predictions at least, and it will help you in the managing your disasters. Now you have urban planning development. So remote sensing supports planning development, providing information on urban sprawl, infrastructure development, land use zoning, transportation network, environmental quality. So it will help you to support the urban planning and the development of the providing information on urban sprawl. Urban sprawl is urbanization. So where the urbanization is spreading over it, it will help you to just find out the how much area is covered, the land use pattern of the urban areas, and how much area is left over, and where can we plan for a better construction. Next, we have the climate monitoring and modeling. So, remote sensing data is used to monitor key climate variables such as temperatures, precipitation, sea level rise, greenhouse gas concentrations. This all are able to we are able to just find out with the help of the remote sensing process. So I think these are few of our applications. We have many more applications of remote sensing, which help us to just get the information and which help us to process the our data, which helps us to make our lives easier, and it is easy to access, and it gives us accurate information of the ground data. So wherever you are finding a remote areas, it will help you to just get the information of the remote area. We need not go to that place. We need not go to such kind of areas. Just it will help you to give the information of that all areas. So next, if we see references about this remote sensing, basics of remote sensing. So if you want to find out more content about this topic, you can just go through these references like M. Reddy, Remote Sensing in GIS, from BS Publications, New Delhi. So this is the book. It's a very good book for understanding about the remote sensing data. So M. Reddy is the author of this book, and he has just written a very good information about the remote sensing and GIS applications. So you can just go through this for finding out the content. Then you have a Fundamentals of Remote Sensing by George Joseph, University Press, Hyderabad. So about the fundamental of remote sensing, if you want to know, it will just you can just go through this book also. For some more references we have here, like in Narayana, LRA Narayana, Remote Sensing and its applications. So S. Kumar, Basics of Remote Sensing, and Tim Chang, GIS. This is very good book for your GIS part. So when we'll be discussing about GIS, we can just you can just go through this book for your reference purpose. And Remote Sensing by B. Bhatta, Oxford University Press. So this is also these are all references for this topic. You can just go through this all. So I hope you understood what is remote sensing process, how it works, what are the different types of remote sensing, what are the applications of remote sensing, what are the sensors we use, what are the different platforms we use it. So you can just go through these references for this. That's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.